Hi, I am Varun Joshi and welcome to day 53 of our Certified Kubernetes Administrator 2025 course. In part 1, we explored the concepts gateway class, gateway, controllers, routes, and how all of these fit together. Now, in this session, we are going hands on with a demo using NGINX Gateway Fabric to bring those concepts to life. By the end of this video, you will see how the YAML definitions translate into real world traffic flow inside a Kubernetes cluster. Let's jump right into the demo. So what I will do is I will go to my browser first because I want to show you what are the prerequisites for this lecture. And if I scroll down, I want to go to day 53, which is today's lecture. And here I want to show you the prerequisites for this. If I click here, I will zoom in. First, you should have kind installed, and here is the installation guide. You will also need Helm, and lastly, of course, you will need kubectl. And I must say that you should have watched part 1 so that your theoretical concepts are clear. With that said, let's see what we are going to do in this demo. So let's understand what we are going to do. Demo Gateway API with NGINX Gateway Fabric. Firstly, what is NGINX Gateway Fabric? NGINX Gateway Fabric is the name of the Gateway API controller offering from NGINX. It is simply called NGINX Gateway Fabric. So what are we going to do in this demo? Firstly, we will deploy NGINX Gateway Fabric in a kind cluster using Helm. Then we will expose the NGF gateway via NodePort for local access. We will be creating a gateway, configuring listeners, configuring HTTP routes, deploying a real-time application. And once the application is deployed, we will be accessing that application on localhost with these paths that you see on your screen. And all this is possible because of Gateway API. Now I want to show you diagrammatically as well what we are going to deploy so that you can create a mental picture in your head. I'll start from the right of the screen. You see there are three sort of deployments. There is one for iPhone, there is another for Android, and then there is another for desktop users. All these deployments, they have two pods each, and these deployments are fronted by a respective service. iPhone is fronted by iPhone service, Android with Android, and desktop with desktop service. I want you to know that all these are cluster IP services. And then what you see here is, here you see HTTP routes. If I scroll above, you see that we were discussing route objects, and that is exactly what we are creating there. So we will be creating three route objects of HTTP type, one for iPhone, there is one for Android, and lastly for desktop as well. And here you see the NGINX Gateway Fabric controller. What we learned in our theory lesson is controller can be thought of as the control plane, which is the brain of the Gateway API. And as soon as this control plane sees an NGINX gateway or simply a gateway object for which this controller is responsible, it will soon create a proxy for that. And what is that proxy? That proxy is essentially a load balancer for you. These are called proxy pods. We understood the concept of control plane and data plane in our theory lecture, where we learned the actual legwork is done by the data plane, and for doing that legwork we have something called proxy pods, and you can also call them reverse proxy pods, because what essentially a load balancer is doing, it is at a very high level acting like a reverse proxy. And then let me explain you the entire flow, what will happen. Now let's say the user Varun wants to access the iPhone path, and we will be accessing using localhost. Why localhost? Because we are implementing this demo in a kind cluster, kind, which is Kubernetes in Docker. And in this demo, we'll be starting from scratch. So you will be seeing how I install a kind cluster. It's just a simple command, and we'll be doing so using a configuration file of kind. So I will be accessing this on port 31,000 on localhost, and my cluster is listening on that port. Why on this port? Because I have configured my node port to be 31,000, and once I access this on 31,000, my configuration will direct this to my gateway, and my gateway is already listening on port 80. Understand that gateway is a logical object, and once you press enter, once you create that gateway, a proxy pod will be created for you, and that proxy pod will be part of a deployment. And we understood in our theory lecture that if you are on a cloud provider, let's say you are on Google Cloud, and then you create this gateway, it could also result in a layer 7 load balancer. But when you are using these third-party controllers like Traffic, Envoy, NGINX, and so on, then what you receive is you get a proxy pods created. And if I scroll up, we discussed this in detail in our theory lecture. Now, our proxy pod will be listening on port 80. Once this receives this request, this will see, oh, this request should be going to /iPhone, and based on our routes configuration, it will be sent to the iPhone service, and then the iPhone service will load distribute it into any of these iPhone pods. And finally, the container, our application, will be listening on port 5678, and this request will be answered. So this is the entire flow that we will be deploying from the very scratch. With that said, let's go to our terminal and start with this demo. I'll go to my terminal. Firstly, I want to run a command kind get clusters. This will show me all the clusters I have. I only have one cluster, and that cluster is named kind. What I will do is I'll write kind delete clusters, and then the name of the cluster I want to delete is called kind, and this will delete the cluster. Kind delete clusters name is equal to kind. Oh, kind delete cluster is the command, and this will delete the cluster for me. Now I want to create the cluster using a configuration file that I already have. So I'll go to Visual Studio Code. If you go to day 53, there is a directory there. Directory is called demo, and if you expand that, there are few YAML files here which we will be using throughout this demo, and the first file that we will be using is 00 kind cluster, and this is the configuration file that we are using to do our kinds implementation. Our kind cluster will only have one node, and here we are saying that 31,000 is the port inside the kind container. So this is listening on port 31,000, and this should exactly match the node port that we decide for our NodePort service, and we'll see this later in this lecture. So this, keep this 31,000, and host port you can choose any. You can also choose 8080. I just chose 31,000 for consistency. Now what I will do is I'll go back to my terminal. I will write kind create cluster. The name of the cluster should be, let's say, Gateway API, and then the config file that should be used to create this cluster is this one. Then I will press enter, and this will create a kind cluster for me. My kind cluster is created. Now I will run kubectl get nodes. This will show me that I only have one node, and that is what we wanted. Now let's do one thing. I'll go to my GitHub repository, because there I have listed step by step what we are going to do. So if I go here, step 1 we have already done. We have created a kind cluster. Then step 2 is install Gateway API CRDs. So I will copy this from here and then I will go to my terminal and here I will paste this. This will install the CRDs. What are CRDs? CRDs are custom resource definitions. And if you see, we have configured 1, 2, 3, 4, 5 CRDs and we understand all of these. First one is gateway class. It defines a class of gateways, cluster-wide templates for your data plane. And what is your data plane? Your data plane is essentially the load balancer if you are using a controller provided by your cloud provider, or this could be a fleet of proxy pods that will be created if you are using any third-party controller like NGINX Traffic or Envoy. Then what you see is your gateway. What is gateway? Gateway is an instance of your gateway class, and we have learned all this in our theory lecture. And the third one is gRPC routes. You will be using this CRD if you want to create gRPC routes, and HTTP routes will be used when you want to create HTTP routes. In our example, we will be using this CRD. Not exactly this CRD. We will be using a CR, a custom resource that will be based on this CRD. And finally, there is a reference grants. This is there to allow cross namespace resource referencing. As we have discussed in our theory lecture, Gateway API allows you to have your application deployed onto different namespaces, and even then you can still use your single proxy fleet or a single load balancer. Now that this is installed, what I can always run is kubectl API resources, and then here what I can do, I can grep for gateway, and this will show me all the associated things that are created for me. You see there is a gateway class, then there is gateways, gRPC routes, HTTP routes, and reference grants. Important thing that I want to tell you right here is gateway class is not namespaced. It is available cluster wide. However, rest of these things are all namespaced, and this is an important distinction as we will see as we progress with this demo. Now let's move to step 3. I'll go to my GitHub repository and let's see what step 3 is. Step 3 is install the NGINX Gateway Fabric controller. Here we are saying Helm install ngf. ngf is the name of the release, that is the short form for NGINX Gateway Fabric, and then this is the location of the chart. And then we are saying create namespace. We are saying you have to create a namespace for us and name that namespace ngf-gateway API-ns. And this is a custom name that I have chosen for the namespace in which our controller will be deployed. Understand that right now we have not done any specific thing to Gateway API. We have just configured the CRDs. CRDs alone will not benefit us. Even if we create a gateway object, a gateway class object, they will be of no use to us until and unless there is a controller created. Similarly, if you talk about native Kubernetes, a deployment will have no effect, will be of no use to you if there is no controller, because controller is the one which is ensuring that whatever you have defined in the, let's say, replica count, those number of replicas are running in your cluster. Similarly, when you have a gateway and all these objects, whatever you define in these objects will have no meaning until and unless there is a controller available which is looking at your resources and taking action based on what you have defined in your manifest files. For example, if I have defined an HTTP route for iPhone, there must be a controller which will associate my HTTP route with my gateway, with my proxy fleet or my load balancers. Hence, having a controller is imperative. And then in this step, we are saying NGINX service type. the service type should be NodePort, and these two fields are defining the service that will be fronting the proxy pod here, the proxy deployment fleet. This is saying that you expose my proxy pod, you expose my load balancer using a NodePort service, and we are on kind, which is why I have mentioned NodePort here. If you were in, let's say, a production implementation scenario, you would have chosen load balancer here, and if you were on cloud or on your self-managed cluster, similarly you would have chosen load balancer. Since we are doing this in kind, a local setting, a development space, hence I am using NodePort here, and here is where I am defining a NodePort for me. I am saying the NodePort service that will be fronting my proxy pod should have the NodePort of 31,000, and the port on which my load balancer or my proxy or my reverse proxy will be listening is port 80. Now I want you to straight away start imagining, in case you were in production and you would have chosen load balancer here, then you would have chosen a different port here. Why a different port? Because production implementation will use HTTPS, which uses port 443 of the transport layer. So try to connect the dots, try to make that mental map in your head. Now let's copy this command, and I will go to my terminal. I will paste that here. I will press enter, and this will install a controller for me. Let's wait for this to create my controller. My controller is created. Let me run kubectl get deploy. I will add -a so that it displays all the namespaces to me. And you see, this is the namespace that we specified. Since there was a create namespace flag, a namespace was created for us. And then here is a deployment, and this deployment is running my controller pod. So if I run kubectl get pods -a, then what I will see is, here is my NGINX Gateway Fabric pod, and you see there is a cert generator that whose status is completed, and I will let you explore what this is. Now let's run another command. I will run kubectl get gateway. It will say what gateway. I want to check the gateway classes, and here I will again add -a, and I want you to notice clearly that there is an NGINX Gateway class automatically created for you 70 seconds back. So this is an important point to notice, that as soon as we deployed our controller using Helm, under the hood a gateway class was automatically created for you, and -a here does not play any role, because we know that gateway class is cluster scoped. They do not belong to a namespace. Now let's go back to our GitHub repository and see what is that we want to do next. Now we want to deploy our application manifest. So before we do that, let's go to Visual Studio Code. Here I want to show you what are we going to deploy. So first, in 01, we are just creating a namespace, and this namespace is called app1 namespace. As you know, as a best practice, you should always deploy your applications in their respective namespaces, or your microservices into their respective namespaces. I will go to 02 iPhone now. Here, what I'm doing is pretty simple. I have a typical deployment. I'm naming this deployment iPhone deploy, and this will be leveraging namespace app1ns. Under the spec section, we have two replicas. We are matching labels iPhone page, and which is why you see here labels iPhone page. My pod will have this label. Under the spec section, I'm creating a single container, and here is the chunkier part. So what I am doing is, firstly, I am creating a directory named iPhone, and then what I am doing is I am creating a file named index.html in that iPhone directory, and this is the content of that file, and this is just saying iPhone users welcome to cloud with Varjosh. And then what I am doing here is I am running a Python based HTTP server that listens on port 5678. This is pretty static and this is best for demoing. And then what I am doing is I'm exposing this deployment using a cluster IP service, and that cluster IP service is listening on port 80 and the target port is 5678 because that is the port on which my application is listening, as you can see here. Again, this is mentioned here just for documentation purposes, for completeness. Even if I don't have this field here, this deployment will be applied still fine, but it is recommended to have these fields so that anyone who looks at your manifests can understand that this application listens on this port. But if I would have written this but not this, then my application wouldn't have listened on port 5678. So this is just for documentation purposes, not for actual port opening. And similarly, I have Android deployment and Android service. This is just displaying Android users welcome to cloud with Varjosh, and again this is exposed using Android SVC. Here as well I am creating a /Android folder, and the index.html is residing inside that directory. If I go to 04, this is similar, but there is a slight difference here. What here we are doing is we are putting this at the root. The index.html is at the root. We are not making any directory here. Now, why is that? What I want is when someone accesses my application, when they add /iPhone, they land into the iPhone service and are served by iPhone pods. If they write Android, they are served with Android pods. But if they do not write anything, that implies they are probably accessing my application using their laptops or their computers. Hence, I want them to be served by the desktop service if they are not supplying anything here. Now, I want you to understand one thing extremely clearly. When you are developing an application, it is not that your users will be writing /iPhone or your Android users will be writing /Android. It doesn't work like that. If I am using an iPhone and I try to access an application, I never write /iPhone. I just open my app and it just works. So I want you to clearly understand, as an application developer, when an application is developed and it is available in, let's say, App Store, it is automatically configured in that application. When someone opens it, you take them to the iPhone service. So I'm just giving you an example here so that you know how application development works. And if someone has downloaded an application on your Android's Play Store, then that application will automatically be embedded to take the user to /Android. So in actuality, in production, this is how the application works, as users are not expected to type these paths. Again, why I am showing this to you like this here, because I want you to understand the bare concepts first. Now, with this understanding, let's again go back to our Visual Studio Code. So these are all the YAMLs. So let's go to our terminal and I will apply all these YAML. I'll first clear my screen. I will write kubectl apply -f01, that is for the namespace, then 02, that is for iPhone, then 03, that is for Android, then 04, that is for desktop. It's so good to see all these YAMLs apply successfully, because I have tuned and tweaked them a lot before recording this demo. In production, it might not work like that. Okay, you'll have to troubleshoot a few things. I will now write kubectl get pods -a, and I see all these pods are, some are in running state and some are in container creating stage. So Android, desktop and iPhone. all are these. And if I run kubectl get svc-a, then I also see that there is a service created for each of these, one for Android, one for desktop, and another for iPhone. And all of these services are listening on port 80. So this part is understood. And now let's go to the interesting part. So what is the interesting part? Interesting part is the gateway piece. So I will go here. This is the 05 gateway. Now what we are creating here is we are creating a gateway, and once we apply this manifest, what will happen is a proxy pod will be created for us, and that proxy pod will be acting as a load balancer, or you can say reverse proxy. So if I see this manifest, this is what we expect, and you know how to check these things. If I go to my terminal and I again run that command kubectl API resources and I grep for gateway, you see here is the gateway, and here is the API version for it, and here is the short name for it, and here is the kind for it. And you see we have filled exactly those things here. Under the metadata, the name is gateway. I am calling this gateway, and then namespace is ngf gateway API -ns. This is the same namespace in which I deployed my controller. In the spec section, I have the gateway class name, which is NGINX. Like I showed you, if I run kubectl get gateway class, then I will see NGINX here, and I can also run a describe here. Let me change this to describe so that you know what all configurations are there in the gateway class object. So describe, I have to spell it right. Oh no, DESCRIBE. Then I press enter, and here are the fields that you would see in your gateway class, and these are the important fields that were auto populated for us. Now based on the controller that you are using, these fields could differ, but the important thing here is the controller name. The controller that is managing this gateway class is called NGINX Gateway Controller. And if I run kubectl get pods -a, and this is the NGINX Gateway Controller which is running here. And what I can also do is I can run kubectl describe pods, and then I will write -n ngf. This is the namespace, and the pod that I want to describe is ngf, because this is the controller pod. I am describing the controller pod. What I want to verify is the controller name here, NGINX Gateway Controller, is indeed this controller. So if I press enter and I scroll up, you will see a flag there. So here is the arguments, and you see gateway controller name is gateway.nginx.org/nginx gateway controller, and that is what we see here in the gateway class. So I hope your dots are getting connected slowly and steadily. So if I go back to my Visual Studio Code, here is that engine gateway class name. Then listeners, what I want is the proxy pod that will get created. Port, it will be listening on 80. The name is just HTTP. Protocol that it will serve is HTTP. If you were using TCP or gRPC, then you would have written those protocols here. Then I have namespaces. I'm saying that all the namespaces can use this gateway. If I had to restrict certain namespaces, if I wanted to limit the usage of this gateway for certain namespaces, then I could have specified them here. But for now, I'm using all, and you can always check the documentation to see what all options are available at your disposal. So I will go to my terminal, and here I will run kubectl apply -f, and then I want to apply 05 gateway.yaml, and this says the gateway is created. Now let's do one thing. I will run kubectl get pods -a. Now I want you to see one thing. Here is the pod that is being created for us, and here is the controller port. So here is the control plane now. And remember what I told you in this diagram in the theoretical session. I told you that as soon as you apply this gateway manifest, a load balancer or a proxy fleet is spun for you, and that is exactly what we are seeing here. As soon as I applied this gateway YAML, a proxy pod was created for me. Understand that I have not yet created any routes, but as soon as I create this, a proxy pod was created for me. Now, what does that mean? There is already a proxy pod that is listening on port 31000, because understand what we have done. We have already deployed this gateway, and this gateway is listening on port 80. And if I want to hit this port 80, what we did in second step, if I go back to my Chrome browser and I scroll up, what did we do here? We said that I want to expose my proxy pod on node port 31000, and my proxy pod will be listening on port 80. So hence, if I go to my browser right now, which I'm already there, and if I write localhost and then I just write 31000, this should work. This is saying 404 not found, but it is accessible. This is accessible because my proxy pod is already listening on port 31000, although there is nothing configured yet. I have not configured any routes, hence you do not see anything. So let's do that thing and configure the route. So let's go back to Visual Studio Code, and I will go to 06 routes, and here you see I have all the routes. So if I scroll up, firstly, I have the routes for iPhone. So what I'm doing is I'm saying the kind is HTTP route and gateway.networking is the API version. Name is iPhone routes. I am creating this in a separate namespace. I'm calling this namespace app1 namespace, and our application pods are also created in this namespace, the iPhone, Android, and desktop. And then I'm saying in the spec section, I'm saying the parent references. Now this is an important part. I'm saying the routes that I'm creating here, they are for the gateway that is named gateway. And if I also open my gateway manifest here, and if I split this to right and then I close this one so that you can quickly correlate. So what I'm saying is the gateway that I want to associate this route is called gateway, and you see gateway is here. And then I'm saying in which namespace is that gateway located. That gateway is created in the namespace ngf gateway API-ns, and that is where this gateway is created. Understand, these are two different fields. This is the namespace for the HTTP route you are creating, and this is the namespace where your actual gateway resides. And the section name is HTTP. What is section name? Section name is the listener, and the listener's name is HTTP. Hence, I'm saying the section name is HTTP. Rules. This is extremely simple, like we saw in our Ingress manifest. I am saying whenever there is a request for /iPhone, you send it to the iPhone service, and the iPhone service will know what to do. And similarly, I have created these routes for Android and for desktop. The only difference is here you see /Android, here you see /iPhone in the path. But when I talk about desktop, you just see /, because I want, if someone is not supplying any path, then they should be served by the desktop service. As simple as that. So let's go to our terminal and let's apply this manifest. kubectl apply -f06 is the name. I'll press enter, and this is created. Now I will run kubectl get HTTP routes, and in which namespace I want to get. So let's get it for all the namespaces because we only have 3 routes we just created. And here you see all these routes are available. Now what I want to do is I want to run a describe in one of these routes. So I will run kubectl describe -n, and it is app1ns. Then I want to describe in HTTP route, and that route is called, let's say, iPhone. I'll press enter, and you see all the specifications of the route that you just created. Now these things that you see here, we already defined in the manifest, and from there it has picked it. And see, you can also do weighted routing like we discussed before, weighted routing as in canary or traffic splitting. And if I scroll down, these are the status messages that are important for you. The message is the route is accepted, the status is true, type is accepted, all references are resolved. This is what you want to see. And the controller that is handling it is called NGINX Gateway Controller. These are the parent references like we defined in our manifest. All of these things. Now that we have applied this, let's check the connectivity. I'll clear my screen first and let's go to our browser. Previously this was showing 404 not found. Let's hit a refresh here. Voila, you see desktop users here. If I write iPhone here, you see iPhone users. If I see Android here, you will see Android users. That is what we have coded. Now I want you to know that controller was watching our gateway resource, and as soon as it saw our gateway resource created, it created a proxy for us. And as soon as the controller saw there is a route manifest, HTTP route manifest, it performed a reconciliation, and because of that we are able to do this. Understand that the controller is the control plane and the proxy is the data plane. Now that we have verified it, I also want you to see the logs. So I will run kubectl logs -n. The namespace is ngf because I want to show you the logs for the proxy pod itself. And we know that the name of the proxy pod was gateway nginx something. Yeah, gateway nginx is there. So gateway nginx, I'll press enter. You see whatever we are doing, we were accessing it, and here are the logs. We accessed /iphone /android /android. All of these things are here, and you can also add -f here if you want to see all your logs live. I'll press enter, and then if I go here, let me just misspell this. I'll just write this, and this is an error response 404. So if I go to the logs, you see 404 right now. And if I go here and access an iPhone, let's say, then I will see iPhone in the logs. So I hope all dots are now connected. And simply once you are done with this demo, you can delete your client cluster if you want to. I think that is all I wanted to cover. That wraps up part 2 of our Kubernetes Gateway API deep dive. We have taken the theory from part 1 and applied it in live NGINX Gateway Fabric setup, walking through how Ingress class, gateway, and routes work in practice. In our next lecture, we will shift gears and set up a multi-node Kubernetes cluster using kubeadm. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.